Hello. So I think I am live right now, and this is working. Yeah, yeah, I'm live. So we are together in this Rust series. If we are, then we will be starting out with primitives right now because we were learning using Rust by example. So today is my day four, but as for you, this is just part two. And this is my day four where I'll be learning Rust by example. Plus I'll be learning concepts to using ChatGPT and of Python also because this is a series of doing AI ML with low level plus high level languages altogether. So I'm learning Rust for that because Rust is memory safe and it's way safer than using C or C++. Plus it's fast. So yeah. So let's start by primitive. But before that, we must set up our own. So this is how you can open up this doc offline. If you have installed it, you have to just type rust up doc and rust by example, and that's what it takes. As for online folks, you can just search about it and you will get the result. Now, since today is you know day four, let's make directory called day 4. Yeah. Oh shit. I made it. Yeah. I'm AD. I made it. 0 4 day. So I guess we are ready. We have now set up our own where we'll write the code. As for the naming, I won't spend my mind on naming stuff. I'll just name it like one underscore one, or two and three, based on the topics and the difference between them. So let's start with primitives. Yesterday we ended at this hello world, and the last thing we learned in hello world was formatting. Yeah, we did this, and we created its display by our own selves. That's what we did, and we created hex code in that display. So yesterday was interesting, but now today we'll be going with primitives, and there are also nice topics I can see over here, but I think it's short. And today's live lesson or live video will only go on for, I don't know, up to 12 o'clock. And right now it's 10:30. So let's start with the primitive. So Rust provides access to a wide variety of primitives. What are primitives? Nobody knows, but we'll learn it. That's what we are here for. A sample includes a scalar type, then compound type, and that's it in this, you know, HTML page. The scalar type is signed integers like I8, I16, I32, I64. What are these numbers? I8 means 8 bit, isn't it? I16 is 16 bit, I32 is 32 bit, which is 4 byte, and then I64, 64 bit, I28, 120, I128, 128 bits, and I size is sort of a pointer size. And there is then unsigned integers. So there is signed integers which are represented by I, and then the size in bits, and then there is unsigned integer, again u, and then the bits, and that's it. This is u8, u16, u32, u64, u128, and then u size, which is a pointer size. Now the third is floating point. So this is what we have used most of the time. We have used F32 and F64 in our projects, so we know it. We've also used I32 and U32 in our project. We also know that also. We've never used I size, like we might have used, but we have never written it properly. And then there is a floating point, we have used it, and char. So this is for character. Uh, I prefer calling it char because char, char, come on. If we add ed, it would become charred. So yeah, char, not car or anything else. It's char for character. And Unicode scalar values like a, alpha, and sort of infinity is 4 byte each. Am I saying this correct? Is this infinity? Yeah. And this is alpha, not a. This is alpha. Yeah. So char Unicode scalar values like a, alpha, or infinity and infinity are 4 bytes each. So any character takes 4 bytes. Like it is of type I32 or the size 32 bit or 4 byte. As for bool, either true or false. This is also a scalar type. Like it can either be true or false. Then unit type is this, which gets returned by default by any function. So if somebody asks what's the default return value in Rust, this gets default. This value, this is unit type, gets returned default in any case of function if you have not mentioned what should be returned. So whose only possible value is empty tuple. So this is an empty tuple. Its only value is this only. So this unit type is equals to an empty tuple, which is its value. And then despite the value of a unit being a tuple, it is not considered a compound type because it does not contain multiple values. So despite the value of being it being a tuple, it is not considered a compound type because it does not contain multiple values, which is good. Now there is compound type, in which there will be arrays and tuples, and I think string, because char is over here, so string is compound always. I don't see it right now, but let's go through it. So there is, wait a minute. So compound type, then there is array like 1, 2, 3, and there's a tuple that is 1, and then this is true, that is boolean. So in array we can, like some store some numbers like 1, 2, 3, and in tuple we can store numbers alongside with strings or booleans like that. Now the variable can always be type annotated. So numbers may additionally be annotated by a suffix or by a default. Then integers default to I32 and float default to F64. Note that Rust can also infer types from context. Now let's try to read this function. So there is a main function, then there is a variable can be type announced and annotated. So let logical is of type bool. It's not equals to bool, it's of type bool, and then that is equals to true. So logical is equals to true. And then if let a float is of type F64, and then we assigned it a number 1.0. So it's a regular annotation. And then there's something like an integer, and we have not mentioned, oh, we have mentioned over here. So it's 5i32. It's suffix annotation. We used in the type in suffix, so it got suffix annotated. I don't know if that works because I've never seen that. Now, or a default will be used. So default float is like F64. Automatically it will be used if you don't use anything and you assign a float value to it. So automatically this will become a type of F64. Same for this. This will be seven assigned to this default integer variable. So this variable will become I32 automatically on default. So a type can also be inferred from context. Let's say let mute infer type is 12. So this seems 12 seems like a type 164, like I64. It's an integer and it can be stored in 64-bit. So is inferred from another line. That is inferred type. That is this. So let's say this is also inferred type, and we see a suffix, suffix annotation over here of I64. So the variable automatically becomes the, I64 type. As for a mutable variable's value can be changed. So it's telling me that a mutable, so there is a variable called mutable and it's mutable because mute, and it is equal to 12. So mutable is I32 of type I32 is 12. Come on. It is an integer, can be stored in I32. There is nothing, so it takes things by default. But it's telling me that mutable variable value can be changed. So here mutable variable is equals to a number, so it's I32 type. Mutable is again 21, it's still I32. But here we are seeing that error, the type of variable can't be changed. So mutable, as soon as we make it true, it's telling me that this will cause an error because mutable is a I32 type and you cannot change the variable type. Then variable can be overwritten with shadowing. Variable can be overwritten with shadowing. So instead of just using mutable and making it come true, we are now making sort of, we are reassigning the variable mutable, but it is no longer mutable, I guess, and we are then assigning it a value of true. Now this works somehow because it is a variable and it is overridden with shadowing. So this is sort of shadow of this one, but it is not exactly the same. And this one will become invalid because same variable name. But now it is mutable and it has a different type. So type changed for this. Now true or compound types, array and tuples. So array signature consists of type t and length as t semicolon length. So let my array, it is of type I32, which is integer, and I guess 5 is the length. So type is t. So if it stores something like character, it will become character, and if it stores something like float, it will become F32, which is float. If it stores boolean value, then it will become boolean. And as for 5, this is the length of the array. So 1 2 3 4 5, yeah, there's 5 elements in my array. So my array has to be like mentioned using first of all type and then semicolon and then length. This is the type of my array, and then we assign it a value of 1 2 3 4 5. This can be considered as initialization of an R array. I guess this can be used as initialization, or it can't be. We just have to create an empty array to initialize it. I don't know. I've never tried it in Rust. I've tried making array in different languages, but not in Rust. So tuple is a collection of values of different types. So tuple can store values of different types. So see, first value is 5, which is of type U32. Now second value is 1, which is of type U8. Third value is true, which is boolean in itself. Now the fourth value seems like a float 32, which is 5.04. So tuple can store values of different types and is constructed using the parenthesis. So, circular bracket. Now there is compilation error when I tried to run it earlier. I did not read this. This is saying mutable is 12 and mutable becomes true. So this thing is illegal, but this is not. So let me comment it out and it will run fine, I guess. saying let my array has a problem. And what is the problem? Expected to have one of these. Oh, is it telling me that we can't have this? Should we have to use comma? But I see, but I don't see that over here. It's like semicolon used. There's something wrong with this. Error, expected expression, found let statement. Why not? Only support directly in conditions like if and while expression. Expected semicolon. See, it expected a semicolon. Then you might have meant to use semicolon as a separator. Oh, expected one of at the rate or this pipe found this. You're getting egregious messages, egregious compilation error that we don't understand yet. But let's see. Yeah, it doesn't let us move forward. So I don't know what's wrong with this. So let's just copy it and create one, not one. Because I don't know what it is and why is it not running. So we'll try to run it over here, but we will get the same compilation error. I don't think this will work. Let's see. Yeah, we got the same errors. This let my array has some issues. I don't know if it expects to be inside if or while loop. Uh, let me just cover it out. Comment it up. Comment it up. Now what? Will tuple also create some? Yeah. Now tuple also creates some issues. My tuple creates some issues. Let's comment it up. Comment it up. Now what? Now what is the issue right now? Tell me. Now playground time now. Wow. Don't worry. We have something else. We so it expected a expression where over here, I guess. Yeah, I guess this is creating some ruckus over here. First of all, there is no semicolon, plus there is no value. Let's give it a value of true. Is it good? Is it bad? I don't know. Let's check it out. Yeah. Now we have a warning, not errors. So probably we have some, yeah, yeah, it's running. We are not seeing any errors, but we are seeing multiple warning because none of our variable has been used somewhere. And maybe overwritten, it's telling me that maybe it is overwritten before being read. And maybe it's overwritten before being read. Same thing. Yeah, I think we must be able to make this work. This shall work now. I don't think there will be any issue while compiling it. Yeah, it compiles now. So there was nothing such as issue with a array or tuples. It was just this line creating some ruckus. It was this line let mutable, and there is no semicolon and there is no assigned value to it. So it was just asking what is this, what is this, and it was creating some problems for codes that were written after that. So this also happens. That's why I tried to do this, and we didn't notice it at first. Yes. Now we know this was the array. This was the problem. Not that our code was bad or something like that. So No output means no error also, so we can move forward with this. I think it's good enough. Now there is literals and operators. So there is integer 1, then float 1.2, characters like say 1, string is A, B, C, and boolean is true or false. Then unit type is this. Unit type is always this empty double and can be expressed using a literal. So what's telling me is integer, float, character, string, booleans, and unit type can all be expressed using some literals. Now integers can alternatively be expressed using hexadecimal, octal, or binary notations. Yeah, so integers can be converted into hexadecimal, octal, and binary. We have done it. We have used it. We know. So this can be expressed into hexadecimal, octal, or binary notation using these prefixes respectively. Yeah, OX, OO, or OB. So OX is hexadecimal, OO is octal, OB is binary. Is this important? Well, this is used to signify that the coming up number is sort of binary or octal or hexadecimal. Otherwise, you won't know much about it. That you would if you had an idea, but yeah. Underscore can be inserted in numeric literals to improve the readability, like this. So underscores can be, yeah, we used NumPy and used this underscore thing to write 1 billion. Otherwise, we wouldn't have been able to count how many zeros were there. So we can use underscore just to improve the readability of the numbers. It is the same as 1000, and this one is same as five zeros after decimal and then one. Now the Rust also supports E notation, which is something like this, and let's see what it opens up. It opens up the scientific notation. So 2 into 10 to the power 0, which is E 0. So all right, E is base 10, I guess. E is base 10, and whatever exponent it's having is getting expressed over here. So it's not 2 raised to the power 0, it's 2 into 10 raised to the power 0. This is 3 into 10 raised to the power 2. So it's E2, and it's whatever, but E3. This is E4, this is E9 because of this. This is E minus 1, this is E2, and this is E minus 9. So whatever is in the base of 10 and has a power, we can write it in form of E, and our Rust supports it. So yeah, we have something like 1 e to the power 6. So it's like 1 into 10 to the power 6. Then we have 7.6 e to the power minus 4. So we have 7.6 multiplied by 10 to the power minus 4. So this is E notation, and Rust supports these scientific E notations. Now the associated type is F64. We can store it in sort of F64. We need to tell the compiler the type of literals we use. Now we'll use U32, which is unsigned, I guess. Unsigned 32 integer, I guess. Suffix to indicate that the literal is unsigned 32-bit integer. Yeah, it's 32, unsigned 32-bit integer. And the I32, which is signed, I guess. I don't know. Integer 32, suffix to indicate that it is signed 32-bit integer. Yeah. So the operator available and the precedence in Rust are similar to C-like languages. So operators available and their precedence is in Rust is similar to C-like languages. You'll see. So there is main function. Let's first of all try printing out. Now there is main function and we are trying to print. So 1 plus 2 is 1, and U32, which is of type U32, and plus 2. So this is an integer addition. We are adding it and this comes up in this bracket. So we must be getting 3 over here. And this is 1 minus 2, and we are specifying that 1 is of type I32, from which we are minusing 2. So we shall be getting minus 1 over here. Yeah. Now we have scientific notations like 1E4 is 1E4 is 1E4 is this, and the value gets over here because this is the 0th element after comma, and this is minus 2 5e minus 3 is this value, and it's go comes over here. I don't know why one e4 is not colored, whereas this one is colored. There might be some error. No, there is not error. It's compiling successfully. So this is just how it looks, I guess. Now, short circuiting Boolean logic. Now, what is short circuiting Boolean logic? I don't know. But yeah, say start circuiting Boolean logic. So print true and false is true and false. All right. So we are not performing any operations, but we are just doing if true and false. So it will give us, what will it give us? True. And true or false, it will give us false. I don't know, yeah, I forgot. Now print ln not true is not true. This is very, like, see, like this is not and this is true, so not true. This will come up over here. So let us see. Yeah, true and false is false. So this is false. 0 and 1 is 0. All right. If that's what you say. Now true or false is true. So it's saying 1 or 0 is 1. And then not true is false, which is this. This is false because it's not true. Bitwise operations can also happen. Now, there is a logical operations like ampersand ampersand. It's used for and, it's used for or, like Boolean logic sort of. But this is a bitwise operator, so it operates on bit. Sort of what we tried to do. Now there is print ln, which is 0011 and 0101, which is a bit, and is, then we are using colons, and then 04b, which is that we are giving it, I don't know, 4 digits. What is 04b? What is 04b? Let's see. It's, yeah, 0011 and 0101 is 0001. So first of all, what we are getting is the AND operation, bitwise AND operation between these two, and the result will come up over here, and we are telling it to be of size 4 uh, in binary. So we are getting binary size of 4, like it's this. Now again, the same thing, but with an OR operation, which is just a pi, and after the operation completes, it will come up over here, and then we are telling it to be of 4 size in binary. It get converted into 4 size of binary. Then again, XOR operation. This is, what is this called? At or cap. We used it as I cap, J cap, something like that. But what is this? Hat or cap? Whatever. So this is used for XOR operation, and whatever the binary is, it comes up over here, and then we only use 4 digits of its binary value. And then there is print ln. Print ln 1 is less than 5. So this is also some sort of bitwise operation that we have never performed, but yeah, 1 is also less than 5 is 1 is type of U32, which is less than 5, comes up over here, and we get a 32. What happens over here? I think we might have to get some help, but all right, still. Now there is print ln, which is hexadecimal. We are using hexadecimal, and then are we using hexadecimal? Hexadecimal can be of type unsigned 32 integer. All right. And then we are operating with this operator 2 and is 0x. What is 0x? Oh, we are signifying this is hexadecimal before uh, getting what the hexadecimal we are getting from this operation. So because of this 0x, we get 0x over here. Otherwise, we wouldn't have get 0x. We would have just gotten this 20 as in value. And that's what we have printed. And people might have misunderstood at it as just a normal number 20. So to signify this is a hexadecimal, we always add 0x before hexadecimal. And for octal, we used 000 and same. Now there is last, which is use underscore to improve the readability. And this means this is 1 million, I guess. Yeah. 1 million is written as, and then we wrote it as 1 million, but still we used underscore to improve its readability. What if we start following the, Indian style, which is this? Now this is not 100,000. This is called lakh. Yeah, is it called lakh? Yeah, it is. 10,000 and lakh. So will it print out what we wanted to print? Sorry. LAKH. Will it print or it prints after only? Yeah, it prints. So we can use these underscore in any readable formats that we understand, and we can use it. So it works fine. This is not 1 lakh, this is 10 lakh or a million. Can we use bracket inside bracket like this? I guess we can because there's these quotation, double quotation marks. So I guess this works. Yeah, 1 lakh, which is 10 million, is written as this. And it is of sign U32. So if we know this will be proper integer, why don't we just make it a signed integer like I? What is difference between signed integer and unsigned integer? Do we know it? We don't. It works. Still, we use U32. Nobody knows why. So let us save it and call it a day. Not call it a day, but yeah. We'll create this 1.rs. So there was something on tool. To try changing one I32 to one U32. See why the type is important. So here we can see why type is important. All right. Will it throw some error? I want to see some errors. Like, where can I use I32? Where can I use U32? Can I use it anywhere? Can it run everywhere? What is this? Yeah, we get an error. So what it's saying is attempt to compute U32 minus U32, which would overflow. Why would it overflow? Yeah, because none of these are unsigned. So let's go like this. And why does this work then? Why does this work then? Because what if we made it plus? It will work as fine. Yeah, it works fine, but it's adding, not subtracting. But as soon as we add minus and convert it into unsigned 32, it throws an error. What if we make the 2 as signed 32? I 32. Now one of them is a signed integer. It still throws an error. Expected U32, found I32. Why are you expecting things here? Now cannot subtract I32 from U32. Why? We don't know. Now no implementation for U32 as I32. Alright. So we can only subtract from uh, you know I32 minus U32. This will work as fine. It doesn't. It doesn't. Expected I32. Arey, yeah. So I guess if this is I32, this automatically becomes I32, which is signed integer. Otherwise, they both are unsigned and they can't subtract or something like that. So we tried doing it and we didn't understand why type is important, but we know type is important, otherwise it throws some errors. And we don't know where to use U32 and I32 simultaneously or side by side or in some other ways. Now we come to another data structure which is tuple. Uh, how much have we got? Oh, it's going fast, I guess. We might also stumble into this, but it's big, so not right now. As for tuples, so tuple is a collection of value of different types. Now tuples are constructed using parameters like these, and each tuple itself is a value and type signature, which is T1, T2, and so on. Where T1 and T2 are type of members. Now function can use tuples to return multiple values as tuple can hold any number of value. So, all right, tuple can be used as function argument and as returns value. So there is a function called reverse, and it takes a variable pair which is of type I32, comma bool. So it is of type tuple, I guess. And it has a return value of bool and I32, which is inside a tuple. So yeah. And now let can be used to bind the members of tuple to a variable. So there is a let, and we are then binding the variables or members of tuple, like I32 is bound to int param, and then bool is bound to bool param or parameter, and we call it a pair, I guess. And then what's happening over here? What is this? We are returning this. Like we, all right. So there is a pair in reverse. We are sending int parameter and then boolean parameter, and we are expecting it to return a bool parameter first and then int parameter. So we just take int and bool, we reverse it, and we send it out. We return. So this is the return value. This is the return value, so and ah, it makes sense, but why is it like this? Why is it like this? So inside the tuple, we have a integer param. Inside the tuple, we have integer parameter and boolean parameter. And from pair, we have both of these. So we are just assigning int parameter to the I32 in pair and bool parameter to the boolean in pair, and then we are just reversing its, you know, reversing the whole tuple, and then we are returning it. So we get a return value of bool and then integer. That's what we are doing here. So tuples can be used as a function argument and as a return value. So for function argument over here, we use tuple, and for return value, we use tuple. And this is the return value. This is the return type. This is the return value. Now let can be used to bind the members of a tuple to a variable. So members of the tuple are bound to variable like int and bool. Good. Following structure is for activity like derive debug. We use this because we can use then the question mark format. Yeah, this format to print out or display our debug type. So this is matrix of like four tuples, I guess F32, F32, F32. So there are float 32 types and four in a matrix. This is our structure that we have defined. And then we have a main function. Inside that main function, have we oh, have we used some pairs or something else? So main function is there, but we've used reverse somewhere in the main. Did we use it? No, we didn't use reverse in the main because we sort of understood this over here also. We didn't use it in main to demonstrate. I don't see it. Yeah, we use it. We use it. Reverse the pair. Yeah, use it. All right. So let's go on with main. So there is a tuple, a bunch with a different type. So one is of type U8, then two is U16, three is U32, four is U64, then minus one is I8. So I have understood something that minus can only use I, like signed integers, whereas plus can just use unsigned integers. Now, minus 1 is I8 type, minus 2 is I16, minus 3 is I32. We have just taken it as sizes, presumably. It's not defined that minus 3 should always be I32. It can be I8, I guess. We'll try it. And then we have 4, minus 4, which is I64. Then we have a float, which is F32. And then we have float of 64. And then there is a character, which is A, and then true. This is a long tuple, which contains everything. And there is not much of an error over here, because tuple can store multiple data sets, data values together. Because arrays only store one type of data sets altogether, tuples can store everything. So it's more loose form of data structure. Now we are trying to print tuple. So tuple of tuple, and then this is a debug display, and then we tuple of tuples. So we print this whole thing. Oh, we came a long way down. So we are first of all trying to print the long tuple first value. So long tuple dot zero will access this, and we'll get the 1 as our input. Sorry, as our output. Println is sending an output. Now long tuple dot 1 is this value, which is 2, so we'll get our second value over here. And then the tuples can be tuples, remember. So tuple of tuples has 2 tuples inside that. So this is first tuple, no, 3 tuples, I guess. This is the second tuple. No. Inside the tuple of tuples, we have 2 tuples and a normal integer. So tuple can store itself also. So tuple has stored a tuple, another tuple, and just a number. All right. Now what? So we are trying to print the tuple of tuple, which is in a debug mode. So we'll print this whole damn thing with the name of it as tuple of tuple. But the long tuples more than 12 elements cannot be printed. Why? Let 2 long tuple be this. This has more than 12 elements. And then try to print ln 2 long tuple. 2 long tuple will not get printed. I don't know why. Uncomments these 2 lines and see the compiler's error. All right, we will see that. And then there is a pair, which is also a tuple, 1 comma 2, and then we are passing that pair first of all. Then we are reversing that pair using our first function that we saw earlier. Here we are reversing that pair. So we are reversing it and then printing it out again. And then to create one element tuple, the comma is required to tell them apart. What is this? To create one element tuple, if there is a tuple of one element, the comma is required to tell them apart from a literal surrounded by parentheses. All right. So if there is one element in tuple, we need a comma after that so that it tells us apart that this is sort of a literal surrounded by parentheses, whereas this is a tuple which has a value of 5, which is U32. So this is one element of tuple and this is just an integer. This is not a tuple. This is not a tuple. This is a tuple because we used a comma over here. Telling it that this has one value, it can come up more with 2 or 3, but not more than 12. I don't know why, but we'll see that. We'll try to uncomment it and see what the error says. Now this tuple can be destructed to create bindings. So there is a tuple which has 4 value, 1, and then a string called hello, and then there is 4.5, then there is true as a boolean. So This is let a tuple be tuple, and then we are storing that tuple's value in A, B, C, D. So A will get a value 1, hello will B, hello is B, C is 4.5, and D is true. Now we are trying to print all of these, and we get it printed out. We get it out. And then we are trying to print this whole matrix as in debug mode. So we get this matrix and we get in debug mode. We have also defined the matrix, so therefore we were able to do this. That matrix is a tuple and we get its value in matrix. That's why we get defined it over here. So yeah, this is an intended behavior. But what is not is this. We don't understand this yet. We will, but too long tuples are not allowed. That's what it tells me. Yeah, it says too long tuple. Too long tuple required by this formatting, and then help. Then it says something like the trait debug is not implemented for integer, 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 and so on. So the following other types implement trait, which is debug. We cannot get this and 5 others. Note this error originates from macro create, which is format arguments NL, which comes from the expansion of macro print ln, and nightly builds run with Z macro backtraces for more info. Now, for more information about this error, please go like this. Could not compile. All right. So it has something to do with being too long. But we have this as a value of 1, 2, 3. How many values are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. What if we added one more value of false? Will it also throw an error? Now this is 13. Let's comment it out. So earlier it used to work. Now we'll see if it does or not. It doesn't throw much of an error because we are just saying there is a long tuple and we are just printing this first value and second value. But it does not care about more than 12 elements. So let's add a character B, and how about adding a string called hello? Will it care now? Because it's obviously more than 12. Yeah, it doesn't care. But why does it care over here? Because we are trying to print it in debug mode, and I guess the debug mode has something to do with it. Let's try. So let's remove this debug mode and let's try to print it. Required by this formatting parameter. We still can't print it. This is not a debug. Okay, so I guess that was a debug for formatting problem. And now if we just create our own standard FMT display, which is not implemented right now, for this integer, we might be able to do this. So this is trying to help us, and we might get this to print. All right, we can do that. Not right now. So note it that in format strings, you may be able to use this or the pretty print instead. So it's telling me we could use this, but then it's throwing some errors that it is, more than 12 times. Oh shit. I can't type this somehow. So let's copy it and paste it. This will again not work. So let's cut it short right now. How about this? Will this work? Yeah, it works fine. But as soon as we add one more element, it is not able to just print it. This tuple can store, 13 values, but it can't sort of print this tuple. In debug mode, I guess there is some issue. If we implement our own display, we might be able to get this tuple, printed. How about going something like this? First of all, and then copy this whole thing, then comment it out. Let's comment it out. Let's run it. It will run as fine. But how about printing our, initial tuple, and it's more than 12. So we are only getting its first value and second value. But let's try to, print the all values. It'll throw an error. Yeah, it throws an error. So I guess it's something related to, create format arguments NL, which is related to this debug display. As for our own display, it has not been yet implemented. All right, all right, all right. You understood it. So let's copy it and paste it as two to the virus. Yeah. So activity is add the FMT display. See, and that will start working. Add FMT display trait to matrix. Oh, to matrix. All right. All right. First of all, remove this or just remove it. You have already FMT display. It also requires FMT display, so why not just remove it for now? Now our activity is that add FMT display to a trait matrix structure in the above example, so that I can do this instead of printing this like this. I It wants me to print easily. Oh, this will get over here. We'll paste it. We'll let it be in a debug mode, but we also want something like this to be in a display mode, and we want to sort of implement the display. Now it's telling me to recap, add FMT display trade to matrix, and so that you switched from printing the debug format to display format. You see output like this. Right now, what is the output that we are getting? Let us see that. Then we'll try to what it tells me. So we are getting it like this right now. But we want to make it look like this, like a matrix. Now, second activity is add a transpose function. All right, all right. Using the reverse function as a template, which accepts matrix as an argument and returns matrix which two elements have been swapped. Now this is complex, but let's do the display. So does anyone remember how we did it actually earlier? We imported something called std display formatter or std formatter. I guess we don't remember it, but let's visit it. Day 3. Mhm. We want to see what is this? What is this? We should have just removed the binary. This is the binary that's getting printed because we had a binary item. So let's print it. Let's first of all remove all the binaries that we have got. We have got 12 called binary. Any other binaries? I guess no. Unless, yeah, no binaries. Now we can cat it out. YouTube list. Derive. We have derived. So we might have made some display too. Yeah, standard FMT. We imported this and then started making our display like this. Yes, this is our libraries. Standard format any FMT, small FMT. That's it. Yeah, standard FMT. But why is this uncolored? Standard FMT. Important. We have important FMT. And then here we'll start defining or implementing the FMT display thing. So let's do that. See if there is any problem with this. IMPL display for matrix. That's what you want. Display for a matrix. Now what? Implement FMT display. Sorry, yeah. This happens when you forget FMT display for matrix. And then we'll start defining how matrix should look. Right. We'll make a function called FMT, which will pass self, and then mute FMT formatter, which will give us a FMT result. So we'll create a function FMT, which will pass first of all self, 10% of self. Then we'll get a F buffer, which will pass FMT display, ISTLAY, and it's telling me that we'll get a result of FMT result. This is it. Oh, not formatter, and it's mutable, so it's FMT formatter, not display. FMT capital F, yeah, formatter, and we are passing it by reference, which is mutable. So mutable reference. How are you to structure it? This is done. This is done. FMT result. Yeah, we are getting FMT result. Now we'll write what? Write a macro of how our cell should be returned. So cell.0, cell.1 should be returned like this. As for cell.2, cell.3 should be returned below that. So can we use \n between that so that we only write it once? So let's do this. First of all, write f is buffer, and inside that we must use self not cell. So just two brackets and then two brackets. Mm, let's say four brackets here. And then we pass it value of matrix or self dot one, self dot one, self dot two, self dot one, self dot two, self dot three, self dot four. Yeah, notice there is no comma. We'll add it. If this works, it's fine. Doesn't, we'll go to a new vim that we can compile at our own pace. Yeah, it didn't compile. So self note available fields as zero. Oh, sorry. So there should be a self dot zero. This is it. Remove self dot four because there is no element called self dot four. Will work. Will work. Fine, I guess. Yeah, it worked. And so let us try printing it out. Yeah, we are getting this as output. We don't want to get this. We want to get it in a format called matrix format. This, put on it. This, if backslash works, then it is well and good. Otherwise, we'll have to do something else. Now enter. If it works, it works. If it doesn't. Yeah, we are getting a bit of space because there is a bit of space right here. Let's erase that space. We are good to go. Yeah, see, same output. Same. And that's what we wanted to implement. So let's save it. Copy it. Not copy this. We will copy our own thing. FT. Since these libraries are new to me, I just had to check out how to implement it. I think it's legal right now because we are learning. But yeah, we should sort of remember it. And we learned it yesterday only, but I don't know how can I forget that. Now this is 3.first, I guess. And get 3.rs. This is important. We have standard empty, we have matrix, and we ran it with our own implementation of display. Rust C 3.rs and then 3. It works. Same thing. So activity 1 is done. It's complete. You may want to refer back to the example for print display. Well, I did refer back, but not from here. So thank you. Now add a transpose function using the reverse. Let's see what this print was. Yeah, it was the same thing. Same thing. Yeah, same thing. So it's telling me to add transpose function. So there is a function called transpose function using reverse function. So transpose uses reverse function as a template. All right, as a template. As soon as we say, transpose it instead of, reversing it. So do we have to define it as a function called transpose? And what it does is, just show me what it does. We have a metric called 1, 1.2, 2.1, 2.2, and it does 1.1, 1.2 comes over here, 2.1 goes over here, 2.2 comes up here. All right. So the first element and the fourth element. So the first element, let's copy it if it can be. Let's paste it if it can be. Can't be pasted. So let's paste it right here so we can get a context of it. So what's happening over here is in transpose that in 2 by 2 matrix, second and third things are getting reversed as in pair. So either what we can do is just send the whole matrix and return this thing oppositely, or what we can do is just do this. Just make it a sound called transpose. So how about we create a function here only? So we create a function called fn transpose, 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 which takes some matrix, which is, four numbers. So F32, 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 like this. But it's a matrix, which is a boolean, no, which is a tuple. We'll say matrix, which is of type, inside this F32, 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 F32. And we have to take a reference of this, of what is happening. So yes, F32 is right choice. And we'll return the same too. So no need to change the value of return also. F32, 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 F32. But it is a very hard coded thing. Is not always matrix will be 2 by 2. When matrix will be 3 by 3, it will be a different thing. And how about 2 by 3? Then it will be a different thing altogether. Now the result we'll be getting is same. How about just copying and pasting it? We'll get this as a return value also. Without seeing it. This is our return value. And now we let something. So we let's say, a tuple of our own. We say element 1, which is element 1, let's say, and then element 2, and then say element 3, and then say element 4. We have to use commas, and directly we can just assign it a value. Yes, tuples can be assigned a value directly. We'll just compare it and assign it itself a value. Yeah. And then what we want to do is return element 1 as element 1, element 4 as element 4. As for in between, we want to return it something like element 3 gets returned first, and then we get element 2. This is what we want to do. Is this all right? It seems like all right to me. Can we do this? Can we do this? Yes, we can. I don't see any errors happening right now. It's just not being used right now, but let's see. There is this error. Let's remove it. Done it. Now let's create let transpose matrix is equals to, first of all, we'll send it to, transpose transpose function. What we'll send is a matrix, whatever it returns, we get it. That's how we did it now. How did we reverse it? We got a pair and we reversed the pair. All right. So instead of doing this, how about we just copy this whole damn thing, paste it. Instead of getting the matrix as a result, we transpose transpose matrix. We get transpose matrix. Do that. This should work. We don't need to do this. Doesn't work. Why? It expected F32, F32, F32. Found matrix. Yeah, that's what it also says. It expected pair of type inside, this. Did we do something wrong? Did we do something wrong? There was a pair. There was a pair. And then there was a return value opposite the pair. You got the return value opposite of the pair. Uh, let's just copy and paste it first of all, so that we don't have to come back and forth over here. Somehow this works fine. Somehow this works fine because what it's doing is just taking a pair. We are taking up a matrix, and then it's telling it that pair has a type of I32 and bool. We are telling it that matrix has a type of F32 all over the place, isn't it? So matrix is of type F32. Shall we just remove this whole thing? Will it work then? No, it doesn't. What it's telling me is expected one of these things, and then like it's expecting me to write a colon or something like that to define its type, and then transpose is matrix type name. How about we go back? It looks somehow the same, but this does not work. This works. Why? Why can be? Uh, is there any reason? I don't see any reason. The let can be used to bind the members of tuple. Oh, it is saying doesn't implement. How did we implement our display? We implement display as this. So whatever the cell dot 0 is, cell dot 1 is, do that. Or instead of small, we take the whole structure of matrix. Or now. Nah. How about this? So I guess it's expecting the whole thing, like the whole number. I don't know why it can't take it properly by itself only. Should be able to, refer sort of the matrix here. Nah, this is again an error. Call expression requires function. So this is a call expression, and it requires function. Matrix is equals to this matrix. We can print the matrix, but we can do this. What about the tuple? So reverse was this, and then there was a pair for this. Damn it. We are stuck. We are stuck. So to need a breakthrough, shall I ask my GPT model? MAT IX. Let's do it for MAT IX. And instead of, because this matrix structure is a tuple in itself. So instead of returning F32, 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 we'll say we are returning this. We close it without running it again. Yes, we are stuck somehow. Instead of saying return value is this, how about saying this is just return value is just a tuple? Will it return it? It doesn't return it. There is an error. So it's telling me this is also not good. If we remove everything, what's the point of even making it? Since we are getting a tuple, it's telling me to make everything a tuple. And then this runs, I guess. But this doesn't do anything. So, and this is an empty tuple, so it's like saying this is unit type, which is not in our case. So let's just ask the GPT model what's wrong with this function. And we hope it tells us. What's wrong with the code? But before that, let me say that I am going to rest my clearly. What's wrong with this code? It will tell us. It must. Good. We realized. Problem line is this. Print. Two issues exist here. All right. Problem line was this. So, trying to do using let transpose is this was not a wrong approach, I guess. So issue one is that matrix is not a function. Yeah, it is not. It is a structure. But matrix is a structure. So this is a variable, not a, yeah, this is a variable, not a function. So calling it like a function means call this value as a function. But matrix is a tuple structure type, and the matrix lowercase is just a variable. So the compiler is something, say like this, expected function found matrix. Issue two is that type mismatch in the transpose. So yeah, matrix F32 expects a tuple, but this. Here it expects a tuple, but we get this. So instead of what I'm doing, I'm getting few points that it is not type a tuple, it is a type matrix. I guess this is what it says. I am guessing it. And let's also fix this uh, by So this is a type in itself. So yes, correct approach would be make transpose accept the matrix. Okay, directly matrix and not define F64 x64, and it returns a type matrix. And then we are doing matrix dot 0 dot 2 dot 1 3. All right, this is about it. So no need for F32 or whatever. It is just a type matrix. And then what it's telling me is no need to do this. You know, just return the matrix and its matrix values. Matrix dot 0 dot 2 dot 1. All right. This should work. Trix element. Oh, not element 1 0 1 2. What is it? 0 1 2. This becomes 3. This becomes 1. This is not done yet. Let it expect matrix. All this. Now there is a unclosed. Now this is just a oh my matrix matrix. Not found in the scope. Not found in the scope. These elements are not found in the scope, so it's matrix, I guess. Matrix 0, matrix 1, matrix 2. T R I X matrix 0. Is this found? Is this found? So help a local variable with similar name exists. These arguments are of type F32, F32 are missing. Matrix dot 0, does that exist? Three argument of F32 are missing. So only one is there, so it requires three more. So maybe RIX, let's say 2 dot 2, then matrix dot 1, then matrix dot 3. How about now? It works. It works. It somehow works. Not somehow. We use ChatGPT for getting this. Yeah. Print. This was what we used earlier, but then because of error, we changed it. Don't ask me right now. So I guess, yes, this works. So we can move forward with this code. And moving forward. This is not something new, so we'll not name it anything special. From the 3.rs, so we'll name it 31.rs. This was just an add-on. Now we shall move forward to array and slices. I guess this will be the last thing. After that, we'll have a custom type. And in custom type, there are struct, there is enum. Structure, we read about structure. In enum, we read about enum. What is enum? Nobody knows. We'll note over here. Then we use, and then C-like. All right. So this C-like is again a new, not a new thing. It's in enum already. All right. Next, test case. These are all topics we'll learn tomorrow, not today. I'll end the stream in 9 minutes. Yes, custom type will be a long lecture. As for primitives, array and slices. So let's cover it up quick. So an array is a collection of objects of same type T stored in contiguous memory. Arrays are created using brackets like these, and their length, which is known at compile time, is a part of their signature. That is T and then length. Length is passed inside the array, and T is sort of the data. And only one time, because array is an object with same type of T. So only one T is required, and it understands that rest of the data is also of type T. It assumes that. Else it will just throw an error. And the stored in contiguous memory. Now arrays are created using contiguous memory is very important because Python doesn't. Python stores pointers in contiguous memory. But here the object of same type like T gets stored in contiguous memory, like data of array gets stored condition. That's very important because it makes it faster, and CPU caching and all. That's what we learned yesterday. All right, so contiguous memory makes the rest faster and array faster in Rust. Now arrays are created using brackets, square brackets, and their length, which is known at compile time, is part of their signature like this. We pass the length of array that we want. If we want array of length 5, we'll write 5. If we want it of 5, 9, we write 5, we write 9, and so on. And slices are similar to array, but their length is not known at the compile time. Instead, a slice is a two-word object. The first word is a pointer to the data, and the second word is the length of the slice. All right. The word size is the same as U size. The word size is same as U size. Now determined by processor architecture, like 64-bit or 86-64 slice can be used to borrow a section of an array and have the type of %t. So this is now a reference of sort of an array but in a slice, and it doesn't pass any sort of length. Now you will first of all import standard memory, and then this function borrows a slice. So let's analyze this function. This is called analyze slice. Then we pass slice, and it is of type, slice. Slice is of type this %t. It is a reference to sort of an array. So therefore, now what we print is the first element of the slice, which is slice 0, like an array. We can toggle slice, and then we print the slice has, how many elements. So slice dot length. This gets printed out. We can see its output. It's running. So now we have a main function. What main function does is we have a immutable variable called xs, which is an array of type i32 with length 5. So we have i32 length 5. Now all elements can be initialized to the same value. Like if we want i32 of length 500 and we don't want to write all the values by hand, we can just initialize it by like this. That's what my doubt was at the starting, and now I know how to initialize a array with the same value like 0 0 0. Now indexing starts at 0. Like indexing starts at 0, this 0, 0th position, and then 1, then 2, then 3. So first element of the array is xs 0. From here it will get 1, and the second element is xs 1, which is 2. Now length returns the count of element in an array. So it will return 5. So we know access.length is 5. Okay, so therefore we had this function called length everywhere, because earlier in C we had to count, the length, but here we can just get it. Now println array occupies these many bytes. So we'll just say memory and the size of value, and we'll pass the array, the reference of array. So it will go to this memory, standard memory library, and we'll do something and we'll return the byte from there, the bytes that array has. And println can borrow the whole array as a slice. Like we had made a function called array slice, and we had to pass a reference of slice. We passed a reference of the array. Now it will slice it and analyze it. So slice can point to the section of an array. All right, slice can point to the section of an array. They are from starting index to ending index. Now starting index is the first position of the slice, and ending index is more than the last position in the slice. Is one or more is one more than the last position in the slice. All right. Now borrow a section of an array as a slice and analyze the slice. Ampersand yes is the array, and we analyze its slice from 1 to 4. So yes has how many elements? 500. We analyze it 1 to 4, which is 0, 0, 0, 0, 4 zeros. Now let example of empty slice. Like we are passing it an empty sort of array. So empty slices of type U32. Empty array is type U32 and has length 0. This is an empty array, and we are checking. This is sort of making a test that assert equality, and this is a macro which checks for our claims. So we claim that in the reference of empty array means this, we are passing it as a reference over here, and we are getting this array. So in empty array, when we pass this as a reference, we get an empty arrays reference. And same for this, but when we try to slice it, we get nothing, but it's verbose. Yes, we can know what's happening. So everything works. Now, array can be safely accessed using .get, which returns an option. This can be matched as shown below or used with expect. If you would like the program to exit with a nice message instead of a happily continue, like for example, I in 0 to access.length plus 1. So, oops, one element's too far. So this should not happen. Now, match is a type which matches the condition. So here we are trying to match access dot get I, and then if there is some value in xval, a type, then we return that xval at I position, and if there is none, then we slow down. We are saying it's going too far. Out of the bound indexing array, and these. So I guess arrays is simple and slices is something very simple, and we can practice it our own time. We can see all the output. So I'll just end the stream right now.